Page 5?
Yeah.
Page 5. Yes.
Okay. All right, so this one right here, so now this is going to be way different than what the notes are. Okay, so wherever your slide is at on this one right here, I'm going to change it all up. So it's all going to be changed up. So that's why you have all those little lines off to the right-hand side. So now for this one right here, we're going to look at a couple things. So we're going to try and be able to graph this by using this information right here. Not that. Okay.
Try to point yourself.
Hmm?
Point that way.
Oh yeah, try and point this way. Okay. All right. So now we're going to use this information right here. This information is going to help me out. That's going to be the one that's going to change my period. So the number in front of your variable, the number in front of the x inside the sine, is going to change your period. It's going to make it go faster. It's going to make it go slower. Okay? So now there's a formula for this all the time. So my formula for period is going to be 2 pi divided by b. My b is this number right here. The number in front of my variable. That is my coefficient. Okay? So in this case right here, it's going to be 2, right? So it's going to be 2 pi over 2, which gives me just pi. So pi is going to be my period. Okay, who did I lose here? Yes.
What did you do?
Now, what is the normal period for sine? 2 pi. And to figure out the period is 2 pi divided by b. B is the number in front of x.
Oh, never mind.
What was the first thing you said? The number in front of the variable.
Is my coefficient. Okay, that's your b.
Where'd you get the 2 from?
That one right there?
The one you divided from?
Yes, because that is the b.
So you plug in 2x on the bottom?
No, just the number. Just the 2. Yes. So 2 is from right there. That is my b value. Because this is the formula for this. 2 pi, because sine and cosine are always 2 pi. So I start with that.
Oh, okay, I see.
And then I go over b. Yes.
So let's just say sine, like, there's a 2 right now. So if there was a 4, and we put it under 2 pi divided by 4.
Yes. Then I would reduce the fraction. Okay, and you'd get something else, right?
Yeah.
Okay.
Now I get
Yes, so now my period is going to be pi. Now, let's look at this one right here. So what is my amplitude?
Your amplitude is 2.
My
Wait.
1. Where'd the 1 come from? In front of sine. Is there any number in front of sine?
No.
When there is no number, there's always one thing in front of it. There's always one thing in front of it, and that one thing is 1. So with no number in front of it, it's implying that it is 1.
What if there is a number?
Then you would use that number. Anyway. Yes, that guy.
So, any number in front of the sine is the amplitude?
There we go.
That's wild.
That's what we're looking for. Okay, so now we have all that. So now, I'm going to actually use that information there to be able to graph this piece right here. So let's see. Is it the next page on this one? No.
Yeah.
This one say to graph? Graphs of... No, we're not graphing yet. I think we graph on... Yeah, we graph on that one, not this one. Okay. So let's take a look at this right here. So this was going to be sine of 4x. So let's take a look. So the first thing I'm finding is what? The what?
Period.
So the period.
So the first thing you find is the period?
Exactly.
Okay, let me write that
Period's
down.
1.
First,
But we learned that yesterday.
5,
No, period's 2.
We didn't learn period yesterday. We learned what period is, but we did amplitudes yesterday.
Okay. 2 different things.
So you put, okay, so then next you would put 2 pi over 4?
Yes.
Exactly. Reduce your fractions.
1 half.
pi over 2. There we go. So the period is going to be pi over 2. Now, do you recall what a period is?
Isn't this a
One
starting
place
point?
to
Number
another.
of times the graph
How long
repeats.
it takes.
How long it takes to repeat. There we go. So start to finish. It's going to take only pi over 2 for this whole thing to finish, right?
Yes, sir.
That's what I'm looking for. Okay,
Altitude is one.
amplitude.
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 Altitude.
Wait. Hey, Pacho.
Yes,
There's only two things that you gotta figure out.
that's all we're doing right now. Write me out. That's all we're doing. Later, we're going to do other stuff.
Second step, we find the amplitude.
Excellent. There we go.
Next page.
Is that easy?
Wait, what'd you say?
Mister, are you recording right now?
Yes, I am.
So, is it voice too?
Yeah, it is. I got this like cool little microphone over there now.
Is it a blue?
You know
No.
Why is that?
Okay.
I proceed.
All right. So,
Pancho,
yes.
that's it.
For that, yes, that's all I'm asking for right now.
Alright, I got you, dude.
All right. So let's take a look at this example right here. So now we're going to graph these. Now I'm going to show you how to graph this.
His mother.
Now, to show you how to graph this, we're going to start with those two things we just did, right?
Yes, sir.
So let's go. Period.
Oh, sister, I lost him.
Okay, so it's going to be 2 pi over 2. Thank you. 2 pi over 2, right?
Yes, sir.
Which is just pi.
Amplitude is one.
Amplitude is 1.
Oh, wait. Yeah, wait. Hold on, okay, horse. Who's making that?
All right, so amplitude is 1. Okay, so please have out your unit circle for this because I'm going to ask you here momentarily. Now, when we're graphing these, your guys are going to do these steps right here. So you can start off with 1/4, 1/2, 3/4, and 1. It's always going to be this. These are your parts.
Is that what you're doing the table?
We're doing a table here.
Alright.
These are your parts. Parts. We're going to break up the graph into parts.
Alright.
I guess you could say we have the same part.
This is not fun. Usually this part of the thing, like, you should have like 2 lines and the rest blank.
Huh?
This big.
You should have like only like two or three of these lines and the rest of the
Yeah,
box
these
blank.
all lines are really unnecessary.
Yeah, 'cause it's all
Anyway,
blank.
all right, so now that you have our parts, your parts, these are standard. They're always going to break up your wave into these 4 parts.
Oh, I see.
Now, we're going to multiply this by the period. So it's going to be times on all of them. So, it is times my period. So, it's going to be times the period. So, let's see what we get here.
Would that be pi over
Times
4?
the period. Okay, 'cause
Pi over 4. We get pi over 2.
3 pi over 4?
Times.
And my last one is just
Wait.
pi. Yes.
So,
Whoa,
let me
you
read the.
better stop.
Can you explain?
Wait.
Okay, these parts are standard.
Oh, I understand. I'm talking about 3/4. Why is it like?
Like this. Just multiply it by times pi. So, it's 3/4 pi.
Oh, so it's 3
That's
pi
a
over
part.
4.
Yeah, 3 pi over 4.
Oh, it's just.
It's like you're just
So,
adding-
it goes on top.
So
It
you're
always
just
stays on
adding the
top.
pi, you're just
Yeah,
adding
yeah,
the pi.
it's not.
Not adding?
You're just multiplying.
Yes, multiplying by the pi. Yes.
How is it graph?
How what?
How is it a graph?
You'll see it here in a minute.
Graph.
So I'm going to break it up and I'm going to show you over one interval here.
Wait, I have a
I
pretty.
kind of get it. It's like quarters.
Yeah, what?
Okay, I have a question.
Go ahead.
So when do we do that?
Every single time you're going to have to graph.
Aw.
So there is an issue next section. These are all easy problems. Okay? They're very easy.
But you said add the period.
Okay? So,
Why are you setting?
So that's like the parts and you multiply times the period and that's what you get. So those are like the easy graph.
Where the 2 will?
yes, we're going to break up the parts into, okay, our parts of our graph. later on, when we're graphing harder things, if you learn these steps now, everything else is going to be easy. But the problem is you have to learn these steps. You have to know this well.
So you do this whenever you graph.
Yes. So, I'm going to start this off with my graph here. So, I'm just going to do it over one period. So, this point right here is going to be my 0. So, if that's 0 right there, what is this side right here?
1. Yeah.
Where? Wait, wouldn't that be
I heard it.
2 pi.
It's going to be pi.
I understand.
Why is it pi?
1 period.
One period. There we go. One period.
Oh.
Wait, whoa.
Okay, good.
Wait, so like,
Would there be anything on that side? Like negative?
No, I'm just going to graph the positive one right now. For these notes right now, I'm graphing it to positive. I'll show you later to graph both.
so wait, from the axis to that to pi, that's 1 period?
Yep.
Okay, you better.
Because we're not doing any phase shifts yet. We will eventually do phase shifts, but not right now. Yes.
Give me like
the parts are like standard.
Standard parts.
So like, so that would only work for the one that says like y equals sine x or.
Okay, sine, cosine, tangent, cotangent, all of them. Secant, cosecant, all of them. Okay, this is how you do your parts. Okay, so now, let's take a look.
Okay, let me ask you something.
Go ahead.
Okay, so basically you're telling me from right there to that is pi. So that,
Yes.
That's the whole. Like that's the parts all together right there. 'Cause
Okay,
Like,
so
that's
let's
the
label
whole-
our pieces.
Yeah, there you go. Okay. So,
I label the pieces inside now.
so now
Hey, listen up, you people. Go ahead.
pi over pi over 4,
Pi over 4,
and then it's pi over 2,
pi over 2.
and then 3 pi over 4. Oh, I see. Okay.
That's why we did that. We had to break up our graph into our parts.
I
Boy,
see.
you better stop.
Why did you say that shit?
We have not, listen, we didn't get into doing any of them
Yeah.
in which that there are compressing or stretching. So all of the ones we did yesterday had a standard period of 2 pi. Yes.
Now, if you were to do it on the other side to the left side, would it be the same, which is negative?
Yes, it will.
No, what about up and down?
Okay, so now, good question. Hey, listen please.
Because I was so low, yes or no?
Okay, the up and down. What is the amplitude?
1.
So how high does it go?
1.
It goes up to 1 and it goes down
The negative one?
-1.
What's
So
that
we would just split the same thing. So 1
Yeah.
over 4.
Yeah.
2, pi over
Yes.
2.
All right, you guys ready? This is the point where you take out your unit circle. This is the point where you take out that unit circle.
So that 2 represents how much it stretches?
Yes, stretching or compressing. So it means it's going, the 2 means it's going twice as fast. Okay, the 2 means it's going twice as fast. So it's going to finish the whole thing twice as fast.
So if it was
So if it normally takes, 2 pi to get done, now it's only finishing in pi. Yes. Period is pi. Okay.
So if it was negative, then it would be slower?
No. Fractions go slower. Negative just goes down instead. So think of it like this. Sine goes up.
Yeah.
A negative sign would go down. Okay. So now, listen up please. So this is the part that your unit circle comes into play. So if you're not paying attention right now because you're playing on your phone, we're going to have some issues. Now, on your unit circle, please tell me, at 0, what is sine?
0.
0.
It is 0, so that means that at 0, this function right here starts at 0.
That's because sine is y, right?
Yep, sine is y.
I'm gonna always start at 0.
Okay.
Sine should start at 0.
All the time.
All the time. It should, unless there's a phase shift.
Oh, my leg.
What?
Killing me.
We'll deal with phase shift later. We're not doing it now.
So basically the graph
We always start at 2
starts
pi.
at
So
sine
Okay.
value.
Huh? Now. Okay, so now let's take a look. Sine is a standard wave. It always does the same thing unless you change it. If it's positive, it goes up. If it's negative, it goes down. So, let's take a look. So therefore, this thing has to go, from here it goes
pi over 4.
up to
1.
1, at pi over 4.
Wait.
What?
Wait, go again?
That's why we have these increments. We broke up the increments into the parts of the wave that were equal, and they are symmetrical. They are always going to do this. It's not going to mess up and like have some weird thing in the middle. It's always going to be like this. Yes.
Where'd you get the 1?
Where did I get the 1?
Yeah.
Now, sine goes up.
Yeah.
Positive sign goes up. It goes up. Okay, so now, what is the amplitude?
1.
So, it goes up to 1 right here.
Oh, go.
Okay, so it is a wave.
Oh, you smart.
It is a wave, isn't it? So if it's a wave, it goes up. And how high does it go up?
1.
To 1. So after it reaches the top, it can only go?
Down.
Okay, so now. But it doesn't go all the way down first. Where does it go down to? 0. I heard 0.
But it hits
Hey, but how do you know, like, how do you...
Oh, okay.
I did this over here
How is it
to
one?
get these pieces
Because
so they will be like this.
So for each increment, there's going to be a dot there?
Yes.
So it's just like a W.
So it's gonna be perfect every time.
So it's gonna go back.
It's
to,
always.
It's gonna go back to -1, and it's gonna go back up to 0, and then never.
Thank you. It's going to go to
It's 1, but it's
-1, and then it's gonna go back to 0, and then go back to 1.
go to 1. Is it going to 1?
For like 2 seconds.
Is it going to 1?
Yeah.
I don't know.
It goes up to 0.
That's when the period ends.
There we go. That's where it ends.
Yeah.
Wait. How do you- how do
Period
you go
is
down?
over. Period ends.
Okay. So once you get all the way to the top, that means it has to go down, doesn't it?
Oh God.
So if it gets all the way to the top, it goes down. So it goes 0, then back down to the bottom. Then once it reaches the bottom, it can only go.
So it has to hit the top and the bottom.
Yep. It's a perfect wave. So let's take a look. There it is.
Wow, it's so pretty.
Oh my God. Wait, is it gonna like do the same thing on the other side?
Yes, it is. But if it's a perfect wave, the left side would start by doing what?
Going down?
Yes, it would go down because we continue the wave, don't we?
Yeah.
So if at negative pi over 4, this would be down at -1, wouldn't it? But the wave, you know what? You just follow the wave.
Another question.
Yes.
So when we do our homework, do you want us to start from the questions that we did yesterday and then do these ones, or?
I gave you those ones first because those ones didn't change the period. They were only amplitudes. Today we're changing periods and amplitudes. Yes.
Okay, so like the amplitude, what does that do? It's like how far it goes up and down, right?
Yep.
So if it's 2, like the amplitude.
It would go up to 2, and it'd go down to -2.
We have another example.
I understand.
That's where I'm getting at. Okay, so let's take a look at this next one.
Oh, Pacho.
Oh no.
Maldito.
Where's the recording? I forgot.
It's recording here.
Hey, sister.
What is it going to be on YouTube?
Yeah, hopefully.
So it's just we're just gonna see that screen.
I don't know. I'm gonna try it.
Hopefully.
Hopefully, see this part that's in red?
Yeah.
That's the part you guys are gonna see.
Oh.
Hopefully, we'll see.
So we're not going to see your hand?
Oh.
You already had that problem. That's why you moved classes.
Exactly, so I don't have to be here either.
Oh, sweet baby Jesus. Come on now. Okay. All right. Now, class, pay attention. What's the first thing I do?
Find the period.
Find the period. So, if I was paying attention, I would know.
That you multiply the period by pi.
Honey.
It's going to be 2 pi over
2 over 3.
2 over 3, right? Now, can you divide fractions?
No.
Yeah.
You have to do what?
We're flipping.
Multiply by the.
Reciprocal.
And the amplitude is 1.
Reciprocal.
Did I say that right?
Sister.
The reciprocal is going to be what?
Wait. Stop that.
3 over 2, right?
What?
Yes. So it's 35
Oh,
over 1?
you're right.
Or 35.
6
So-
pi over 2.
Wait.
What's 6 divided by 2?
Oh, 3.
3 pi.
Wait.
Makes sense, right?
Yeah.
Okay, give me like 2
Alright, so that's
seconds
the
to like
period.
figure it out.
What's the amplitude is 1.
What is the amplitude?
One.
There we go.
Because there's nothing
Okay, start with my fractions. 1/4, 1/2, 3/4, and 1.
That's never gonna change, right?
Nope.
Wouldn't we continue or no?
Huh?
Don't you
Wouldn't we
multiply
continue?
those?
Okay, so parts again.
If you're going to do it over 2 periods,
Yeah.
if you would do this because you are going to do that eventually, you would go, let's see. So it would be 1/4, 2/4, 3/4, 4/4, 5/4, right?
Yeah.
6/4, 7/4, 8/4.
And then it'd be, and then you would just do 3.
And 8/4 is 2, isn't it?
3 pi.
That's 2 periods. That's what I'm looking for. But when we actually get into that, I will
Let's stay with
list
1
it.
right now. Let's stay with 1.
I know. That's what we're getting at. Okay, so now right here, I multiplied this by.
Wait, well, like, give me like 2 seconds.
It's just 3 pi.
My pen is running out of ink, sisters.
Multiplied by 3 pi.
3 pi over 4.
Wait, how's that just 3 pi?
Wait, multiply by 3 pi.
Okay,
Oh,
you
never
ready?
mind. No, never mind.
Period is 3 pi.
Okay, so 3 pi over 2. We get, yep, 9 pi over 4. And my last one is? So, I'm only going to do my positive now.
Will we ever get
Okay.
Well, what are we doing? Positives?
My pen
Will we?
Yeah, you'll have negatives. You'll have negatives
Let me
later.
guess, like the end over there is 3
I don't have a
pi.
pen.
Right, the end.
End is going to be
3 pi.
3 pi. And right here, this is 0.
You know what if I? I'm so dumb. Like, I thought you were circling.
You guys
Oh, I was circling the 2.
I'll circle the
Oh, what's this?
That's Cho-Cho.
What's the 2? It's a pencil.
Okay.
But
Just keep that next to like study touches.
Did you get a haircut? You look different.
He's just tired. 3 over 2.
Okay, so I have my increments, right? I have my increments. Let's put in our increments. They're always uniform. So 3 pi over 4, 3 pi over 2, 9 pi over 4.
Yeah.
And I get my 3 pi there, right?
Yep.
Now, what is my amplitude?
1.
1.
Amplitude is 1, right? So it goes up to 1 and it goes down to?
-1.
Now, unit circle, please. Unit circle time. On the unit circle, yes.
What's that the
Is
same?
that first increment? Is it 3 pi over 4?
Yeah, 3 pi over 4. Because it's 3 pi times 1/4. Okay, you guys ready? Unit circle. Please find 0.
0.
Now, what is the cosine at 0?
1.
It's 1, right? So it's 1
Yeah.
times my amplitude.
1.
2, 3.
It's going to be 1, right?
Wait, yeah, never mind. Yeah, 1.
Oh.
1 times 1.
Because cosine is 1, isn't it?
Yeah.
So, so now it starts here.
Okay, wait. Just a second. Why do we get the cosine
On the unit circle.
of 0? Yeah. Why do
Did we do that with sine?
Yeah.
Yeah, but like why?
My sign was 0.
Okay, sine at 0.
Yeah.
It's standard. Always. Because for these, what we're doing right now, sine always starts at 0. Cosine starts at 1.
So we're gonna look at the unit circle, look what's on there, and then times whatever's on that.
Yes.
Oh, so like cosine always gonna start at 1.
Yes, cosine always starts at 1.
One sine always starts at 0.
That's what I just said.
Okay.
Hey. All right. So, let's see.
You just
The
broke
pattern.
this year.
The pattern. If I start at the top, now I can only do what?
1, 0.
Go down, right? So now from here, I go from 1,
to 0.
0 here. What goes after that?
-1,
-1.
0, and then +1. And
Then back up to +1.
The period, sister.
That's my whole period right there.
Is it an issue?
Mr. Quattro?
Yes.
Can I use the bathroom?
Go.
You guys already say bro.
Does that make sense?
I'm so confused on why you start at 1.
Okay, so now, unit circle, right? So cosine always starts with the same thing. It's going to be 1, unless there's a change in amplitude. Okay? If there's a change in amplitude, then it's going to be...
I have just made a discovery.
I thought we were on sine. I'm sorry.
No, yeah. Now, sine is 0. Okay? Sine will be 0. Now, we have to deal with sine also. Hey, listen. She has a good question. Okay. The sine is important because even though it starts at 0, is it possible to still have the amplitude on that one? Yes, I would have 0 times whatever my amplitude is. But what if it's a negative amplitude?
Then it just slows down.
Didn't sine start by going up?
Yeah.
What do you think a negative sign would do?
Start from the bottom.
It would from here and it would go down first. That's what it would do. If it was a negative, it would go down first. Now what about if this was a negative cosine? So would it start here at positive 1?
No.
It would start at negative 1, wouldn't it?
Yes.
It would start at negative 1 and therefore it would go up, right? And that's what we're looking for here. Does that make sense?
Is there a possibility that
That's only for the app.
Wait, hold on, got 2 people talking at once. Rocha.
is it possible to have like 2 negatives at once? Like 2 negatives at once?
Yes. Because it could be a negative, right? Right? It could be a negative. Are you saying from here and going down? Okay, because it's a wave, it's not going to do that.
So if the amp is 2, is it going to be 1, 2?
Okay, so now, are we talking about cosine or sine?
Oh.
Okay, so cosine, if it was cosine, for this one right here, if the amp was 2, I would start at 2, right?
Yeah, so what I'm saying is you would put all the numbers before the amp. If the amp was 6, you would put 1, 2, 3, 4, 5, 6.
If the amp was 6,
Oh, she's saying if it's like the lines.
When you're graphing.
oh yeah, okay, so since I'm just having you guys sketch this yourself, this dot right here, instead of saying 1, I would just call it a 6.
Yeah, because you don't have to put
Just label it 6. You don't have to have all the tick marks.
Alright.
Just label it 6, label that one negative 6.
Alright.
Make more sense?
Okay.
All right. Did I answer all questions? Yes.
So like when you say like it might start at -1, is that because of the amp?
Yes, because the amplitude. If my amplitude here was negative cosine, so if I had a negative cosine, my amplitude would be -1, right?
Oh, because it's cosine.
So therefore, like I said, times my amplitude, which puts me here normally, but with the -1, it would start down here, right? That's what I'm going for.
Depends on like which one it is.
Bueno. Was that a hand?
Bueno.
No?
Bueno.
Malo.
Bueno.
Bueno?
Bueno.
Good?
Yes. You're in?
Ow.
Bueno. Yeah.
Oh. I don't know his last name.
Okay. Anyway. All right. Are we okay?
Yeah.
All right. So we're good. Let's see if I could actually get this thing to work now.
So what you were saying about like fractions.